Imagine this, your company just moved its customer app into Azure. The servers spin up in minutes, traffic scales, the board is thrilled. But the databases, the mainframes, the identity systems that still run the business, they live in a building across town. Cables, racks, locked doors. Suddenly you face a boundary problem. If the cloud and the data center cannot talk, the migration is a dead end. If they talk too freely, every private system is one misconfiguration away from the open internet. Scale wants more machines and more regions. Separation insists every conversation be authorized. So the real question is not how to get to the cloud. It is this. What invisible architecture lets an application talk to the right machines and nobody else? Azure's answer is the virtual network, VNet for short. Think of it as the cloud's representation of the private network you used to build with switches and cables. It is a logically isolated slice of Azure. Your virtual machines and services sit inside it, with their own private IP address space, their own DNS settings, their own sense of inside. A VNet can connect to other VNets, and it can reach back to on-premises networks, but only when the address blocks do not overlap. That non-overlapping CIDR rule is the quiet foundation of hybrid networking. Without it, packets would not know which world they belong to. Isolation is the starting point. The boundary exists, but a boundary alone does not tell a packet where to go next. Inside that boundary, Azure networking works through four moving parts. First, the virtual network itself, the isolated container for machines and resources. Second, subnets, smaller rooms inside the building, grouped by function or security. With subnets, you can steer which traffic is allowed near an application. Third, routing, the map that directs packets between virtual machines and other resources. Fourth, the long-distance links, a VPN for a secure tunnel, or express route for a dedicated private connection back to the corporate network. Picture a city. The VNet is the city wall. Subnets are districts. Routing is the road system. VPN and express route are the guarded highways out of town. Together, they let you build something flexible, scalable, and still secure, tailored to how the company actually works. Once the network exists, Azure turns it into an operating system for applications. Meet the Guardians. Azure Load Balancer spreads traffic across many virtual machines so no single server becomes a bottleneck. Azure VPN Gateway builds a safe tunnel between your on-premises network and the VNet, using the IPsec protocol, encryption wrapping every packet like a sealed courier bag. Express route is different. A dedicated private line, not a tunnel over the public internet, preferred when you need speed and stricter privacy. And Azure Firewall sits as a virtual checkpoint, examining traffic against application and network policies before anything moves further. Each service answers a different fear. Overload, eavesdropping, shared paths, unfiltered chaos. But guardians only matter if you know what the network is for. So what do organizations actually do with a VNet? 3 stories show up again and again. First, a dedicated private cloud-only network. No hybrid link required. Virtual machines talk to each other securely inside Azure, and only the services that truly need the internet get an endpoint. Second, extend the data center with security. A site-to-site VPN, sealed with IPsec, joins the corporate gateway to Azure so capacity can grow without leasing another floor of hardware. Third, cross-premises scenarios. Cloud applications reaching Unix systems or mainframes that will not move for years. That is hybrid reality, not pure cloud, not pure on-premises, but a controlled conversation between both. The pattern is the same. Private space first, then deliberate doors. Inside the VNet, the next design decision is segmentation. Subnets carve the address space into unique, non-overlapping ranges, written in CIDR notation. One subnet might hold web front ends, another holds databases, a third holds management jump boxes. Traffic between those rooms is not automatic free flow. Network security groups, NSGs, act like door policies. A rule can allow or refuse communication based on source IP, destination IP, port, or protocol. Want only HTTPS into the web tier? Write it. Want the database reachable only from the app tier? Write that too. Azure Firewall can still sit above this as broader policy, but NSGs are the fine-grained locks on each door. Here's the part that matters. Security in Azure networking is not one giant wall. It is a series of intentional rooms. Zoom one layer deeper. Every virtual machine needs a way to plug into the network. That is the job of the Virtual Network Interface Card, the ENIC. A single VEM can wear more than one, reaching different subnets or paths the way a laptop might join both Wi-Fi and Ethernet. Then there is Azure Application Gateway. Not a general load balancer, but a specialist for web traffic. It can offload ESSL encryption, route by URL path, keep a user stuck to the same backend with cookie-based session affinity, and stand up a web application firewall against common attacks. Together with the VPN gateway that links on-premises to cloud, these pieces turn a blank VNet into a place real applications can live. On paper, the architecture is complete. The next question is almost theatrical. Can you create one without touching a physical switch? Watch the portal. This is where the abstraction becomes a click. You open Microsoft Azure, and the home screen is a grid of services. Virtual machines, storage, databases, keys. The path begins with Create a Resource. By default, a subscription can hold up to 50 virtual networks per region. Need more? Support can raise the ceiling to 500. That limit is a reminder. Even cloud boundaries have quotas. Next, you search for Virtual Network. Choose Create, and the blank form appears. Subscription, Resource Group. A name, something human like VN1. A region, Central India in the demo. In a few fields, the network acquires an identity and a home on the map. No rack, no cable pole, just decisions. Identity is not enough. A network without addresses is a city without street numbers. On the IP addresses tab, you declare an IPv4 address space in CIDR notation. The documentation shows an extreme example. 192.208.9.0/32. A single address, useful only as a notation sample. In the live form, you more often see something like 10.0.0.0/16, tens of thousands of private addresses ready to assign. Then you create at least one subnet. The source is firm on this. Address space and a subnet are required. The subnet range must sit inside the VNet space and must not overlap its neighbors. This is the moment the empty outline becomes a real private grid. Next comes the Security tab, Bastion Host, DDoS Protection, Firewall, each offered as Disable or Enable. These are optional layers you can turn on when the threat model demands them. Then Review plus Create. Azure runs validation, green check. The form you filled becomes a contract the platform can deploy. Click Create, and the deployment blade takes over. Minutes later, your deployment is complete. What just happened is easy to underestimate. You defined a private building block that behaves like a traditional data center network, but with cloud scalability, isolation, and availability baked in. The switches were never in the room. The boundary still is. With the VNet alive, addressing decides who can knock. Private IP addresses keep conversation inside Azure, machine to machine, service to service, never requiring the public internet. Public IP addresses open a door to the outside world when something truly must be reached directly. Authorized access is enforced with network security groups, firewall rules, and VPNs. The VNet also plugs into the wider Azure toolkit: load balancer, auto-scaling, VPN gateway, application gateway. You can reshape IP plans, subnets, and routes as the application evolves. You can span multiple regions. You can scale resources up or down without scheduling downtime. Remember the opening stakes: the app in the cloud, the mainframe on the floor. That conversation is now possible without dissolving the walls between them. So the cloud's boundary problem has an answer. Azure Virtual Network recreates private space in a world of distributed machines. Subnets and security groups decide the rooms. Routing decides the paths. VPN and ExpressRoute decide how the old world calls the new one. Load balancers and application gateways keep applications breathing under load. Scale and separation are no longer pure rivals. They share a floor plan. And yet every answer opens a harder question. As networks stretch across more regions, more services, more automated connections, how should organizations keep every new link secure without slowing the very scale they came to the cloud to achieve? That is the tension still unfolding in every hybrid architecture worth building.